Eighth graders, this is to help you with question 7 on CR19. It says triangle ABC is graphed on a coordinate plane. I actually don't want these primes here. I did give you an actual graph that we could reference, but on your actual CR, they're just asking you to be able to answer the question even if you can't see the figure. So I have a figure shown, your CR doesn't. Addie reflected ABC over the x-axis, then rotated it 90 degrees counterclockwise about the origin. She labeled her final image KLM. So she took ABC, reflected it over the x-axis, and rotated it 90 degrees. Well, you know, after a reflection and a rotation, the original image will be congruent. So that's an important fact that you need to know. As long as we're not blowing it up or shrinking it down with a dilation, the two figures will be congruent. Markey dilated ABC by a scale factor of 2, then translated the resulting image 10 units down. So now Markey decided to dilate ABC by a scale factor of 2 and then translated it 10 units down. He labeled that image PQR. It's important to know as soon as we start blowing things up or shrinking things down that we are going to create similar figures but not congruent figures. So it says identify the pair of triangles from the three ABC, KLM, PQR that are congruent. Well, I'm going to tell you ABC and KLM will be congruent because reflections and rotations produce congruent figures. And in a minute, I'm going to show you on the grid that they're definitely going to be congruent. They're going to have the exact same side lengths, the exact same angles, the exact same area, the exact same perimeter. Then identify the pair of triangles from the three ABC, KLM, PQR that are similar but not congruent. As soon as we have this scale factor of 2, as soon as you're dilating it, you know Markey's figure will be similar but not congruent to the original. So ABC and PQR. Also, I'll tell you KLM and PQR. Either pair of those are similar but not congruent. And the reason is because the scale factor of 2. As soon as we do a dilation with the scale factor of 2, we've blown up the figure and then they'll be similar. Sides will be in proportion, the angles will remain the same, but they will not be congruent. Side lengths will be in proportion, they won't be the same measure. Now describe a transformation on Addie's triangle, KLM, okay, on that triangle there, that would make the resulting image, K prime, L prime, M prime, congruent to Markey's. Well, what we have to do is we're going to have to take Addie's KLM, dilate it by a scale factor of, let's see, what's the scale factor have to be? Okay, a scale factor of 2 about the origin to produce K prime, L prime, M prime. Then you're guaranteed that K prime, L prime, M prime will be congruent to P, Q, R because they both are a blown up version of the original with matching scale factors. All right, now I can actually show you if you'd like if you're like, all right, that's enough info, I don't want any more. All right, you're set. Or I can show you what we would do with this. So if I took ABC and I reflected it over the x-axis, A is 1, 2, 3, 4 above. A prime will be 1, 2, 3, 4 below. B is 6 above. B prime will be 6 below. C is 1, 2, 3, 4 above. So C prime will be 4 below. Now I have that triangle. I don't yet have KLM because now I have to rotate 90 degrees counterclockwise. 90 degrees counterclockwise. We would first reverse. Going counterclockwise, that's the direction of counterclockwise. Arrow, change the sign. So here if I have -4, -4, that becomes first reverse, arrow, change the sign. So that's 4, -4. 4, -1, 2, 3, 4. A becomes K. So this is going to be K. If I look at B prime here, -4, -6, -4, -6, first reverse, arrow, change the sign, 6, -4. So now we got to go 6, -1, 2, 3, 4. And that will be, B becomes L. That's L. And now here we have 2, 4. 2, 4. First reverse. Sorry, I didn't just reverse it. I also did change the sign. So first I reverse, arrow, change the sign. -4. Well, I've done something wrong here. 2, 4, first reverse, or 2, arrow, change the sign. -1, 2, 3, 4, up 2. There's no way that's the same triangle. 2, 4. Oh, because it's this. Oops, my bad. It's C prime I care about. I'm like, well, that's not going to be the same triangle. C prime is 2, -4. Okay, I feel a little bit better about that. Whew. 2, -4. 2, -4. First reverse, now arrow, change the sign. Okay, 4, 2. Sorry about that. C becomes M. C becomes M. Oh, it's so ugly. It's so ugly. But this triangle, the original, and the KLM, those are totally congruent. Side lengths exactly match. Angles need to exactly match. Area and perimeter will exactly match. I'm so sorry about that. It took me a minute. Well, at least you can see teachers aren't perfect. When I wasn't focused on the correct point, I knew, well, I didn't have a triangle that was going to be congruent. All right, so let's pretend we take our original and we dilate it by a scale factor of 2. So if this is -4, 4, it will be -8, 8. So I'll call that A double prime. -4, 7 would be -8, and then we'd have to go all the way up to 14. B double prime. Alrighty. This is not a great video, but I'm not re-recording it. Let's see. Sorry about that. If I was going to do C, C is 2, 4. So C prime would be 4, 8. And that would be C, we'll say double prime. You've got to be kidding me. I am so sorry about this. Well, not good today, my friends. So hopefully, although this is not beautiful, and I'm not even going to finish Marky's because it just will take too long. But hopefully you can see. Before I translate it 10 units down, it's already a blown up version of the original. Okay, it will be similar but not congruent. Similar but not congruent. Tried to give you a visual. I may have just muddied the water, so hopefully many of you stopped after the first part of the video. Good luck.